Hello and welcome to the first episode of this tutorial series. Now, over the course of several of these videos, I'm going to be teaching you Excel VBA, and I'm going to start off with the most basic concepts, just how to start writing code, and then gradually get more advanced as these videos go on until hopefully we're at the point where you can write whatever Excel macros you need. So just to start out with a little context, VBA is obviously a programming language, and it's one that Microsoft has embedded and has left embedded over the years into their major Office products. So that would be Excel, Word, PowerPoint, Outlook, and Access. And then also sort of a couple auxiliary programs that you probably don't need to worry about. Now, the specifics of the language vary a little bit between those different applications. So, Word VBA is a little different from Excel VBA. But largely, if you can program in one, you can sort of fill in the gaps by Google and learn how to program in the other ones. So that said, this tutorial series is going to cover some things that are specific to controlling Excel. And while you can do these in other applications, it's going to be more advanced than just simply doing it here. And, we might get to that level anyway. So to actually begin the tutorial, you're first going to need to actually add the developer tab up to your ribbon here. And to do that, you got to go File, Options, Customize Ribbon, and you'll see down here, check the developer box. Now, if you already had developer up here, obviously, you don't have to do all that. But by doing this, we now have access to this Visual Basic button, which it's the button that will take us into the development environment so we can actually write Visual Basic code. Now, when you open it, I'll just expand it. You can see this is sort of it's a pretty dated window. Excel VBA has been around for a long time. And, you've got this blank screen here, this panel that's, not really all that useful. And the immediate pane, this is super important. So if you don't have this, right now press Control-G to bring it up, because this is how you're going to debug all your code and how you're going to read any console output. It's also possible that it might be like just down here. So if it is, drag it up. Now, to actually start programming, you're going to have to go Insert and then Module. And we'll cover what the rest of these do sort of in a later episode. But for now, again, just worry about Module. This next step is totally optional. A lot of people like to write Option Explicit at the top of their programs here. And if you haven't programmed before, what this does might be a little confusing. But just to explain it broadly, this tells the interpreter, which is this program that we're writing the code in, that you are going to explicitly declare any variables you use. And if you don't, then it's going to throw an error. So that's really good for if you have a typo in a variable name, it will throw an error rather than your output not making sense. If that doesn't make sense, don't worry about it, because you'll learn enough that you'll understand what this does, probably even over the course of the video. Now, personally, I find the typo errors pretty annoying, so I don't work with it. But a lot of people, if you ever open somebody's Excel macro at your job and the person knew what they were doing, they probably do use Option Explicit. So now, if we actually want to write some code we can run, and enough with the preamble, we're going to have to do what's called declaring either a subroutine or a function. Now, both subroutines and functions are similar in that they're snippets of code that can be called on to do something. So you call or invoke a subroutine, or you call or invoke a function, and it will run the code that's inside. The difference between the two of them is that functions return a value, while subroutines do not. So take, for example, when you're just working on your spreadsheet, and you type, say, equals sum, and you give it a range of values. So you'd say values as range. And then it's going to return what's called a double, or a type of number. We'll cover this in more detail here. So when you do that equal sum and you give it all the values, it will go over each element in that value, add them up, and then return the result. Now, there's a few sort of idiosyncrasies, with this. So we're going to cover it sort of in a later video as we get to talking about more complex ideas, because this video is already going to be long enough. So we're just going to start with the subroutine, which really is not that idiosyncratic. It still has the parentheses for arguments, which is another thing we'll cover in more detail later. But if you type, say, as double here, it's going to throw an error because subroutines cannot return values. So in our subroutine, we can do all sorts of things. We'll keep it simple for now and sort of stick to talking about variables and console output. But this is going to form the basis for everything we do up until, if we're writing cell functions and use a function. But I digress. So variables, like their name would imply, are things that can vary over the course of the program running. And if you program before, you're going to be very familiar with this. They'll hold either value or state. And variables that hold value are one class. They're called primitives. And variables that hold state are another class, and they're called object variables. So to declare a variable, we have to dimension or dim out the memory, and we have to give it a name. This name can be a lot of different things. You name a cat, but it can't be keywords in the language. See, if you move off that, it throws an error. Or if you call it cat, it doesn't throw an error. That's the very basic thing. But beyond that, if you want to have sort of an easier time debugging your program, you can also tell the computer what kind of number it's going to be. So I'm saying cat is an integer. It can hold, negative 1,000,000 to positive 1,000,000. That's not the actual range, but it's whole numbers, either positive or negative. And now if we try to say something like cat equals test, it actually doesn't throw an error, but if we run it, then it does throw an error where the computer says, this is supposed to be an integer, you can't put that in there, and you'll catch more errors in your program that way. But again, I digress. So primitive variables obviously includes integer, which we'll change from cat to a. It's a less whack name. They include, there's actually a lot of primitives, so I'm just going to say the most important primitives include integer, double, currency, string, Boolean, and date. So these all explicitly hold values. Integers, like I said, whole numbers from negative really big to positive really big. Doubles are nice because they hold what are called floating point numbers, and they can be integers but also include a fractional component. So 1.5 would be a double. Currency, also very interesting because currency is almost exactly the same as a double, but it's a lot more precise. So doing math doubles, or floating point mathematics, as it's broadly referred to in the computing space, is a fundamentally inaccurate process. And so you get all sorts of rounding errors when you do it, up to like the millionth decimal place. But you do hundreds of operations on a number, and if it's a currency value, you might lose a few cents on it. And this is if they're stored as doubles. And if you lose that few cents and then multiply it by millions of transactions, you have a problem. Currency types don't have that problem, and really that's why they exist, is to work, as their name would imply, as currencies where higher degrees of accuracy are important. Again, this probably probably a little more complex of an explanation than you need right now, but it's good to sort of understand the core tenets of a language before you really dive in. So now strings are sort of a common type across all programming languages, as integers and doubles are. Currency is unique. But strings hold strings of text. So what I am saying right now could be typed out and held in this variable d here, if you so desired. Booleans, they're a little more narrow. They hold true or false, and they're used in conditional statements mostly, which we'll talk about later. And then finally, dates hold dates, right? So if you want to keep track of what day it is, or if you add 1 to a day, it increments, June 1st plus 1 is June 2nd. It makes doing that sort of math a lot easier, and you don't have to keep track of a bunch of crap. Dates are in the same sort of format as an Excel date, which if you've ever converted to a number is it's actually like number of days past. I think it's like January 1st, 1900, and then a fractional component that holds sort of the time of day it was. But again, that's a little more complex than we need to talk about. So that kind of covers it for the primitive variables. Next up, we're going to talk about object variables, which hold state. And some of these exist in sort of the default programming space, the workbook being a good example. Another good example being the worksheet. Or, as we saw earlier, the range variable. So here, like a workbook would obviously represent the workbook as a whole. A worksheet, sort of a specific worksheet, and a range as either one cell. I don't think you can type out cell with 2. I think that gives you problems. I could be wrong, but I've always worked that way. I digress again. Sorry, I like to rant. Yeah, and a range can represent either one cell or sort of a myriad of cells. And the difference between these and primitive variables is that these can hold values. So a workbook can contain how many sheets it has, but it can also have states. So, is this worksheet the active worksheet, or is it not active? Or, is this cell selected or not? And sort of to go into a standard computer science example of this, say we were building like a video game, and in that game there is a dog. We could represent this dog by creating an object variable of the dog type and naming it dog1 or anything like that. And then this dog could have all sorts of properties. Its fur could be brown, it could be lying down, or, it could be 10 years old. All of this can be represented within this object variable, which we can also create object variables in Excel by working with the class module, but we'll talk about that later. And then the one more thing, sorry, this is kind of a complicated thing I'm trying to boil down into a few sentences. If this is hard to follow, I apologize. But sort of the one more thing I want to talk about is that it can also hold subroutines or functions, or just snippets of code. So we could tell our range here to update to reflect new values, or in our example, we could tell our dog to lie down, or we could call our dog and give it a name and ask it if that's the dog's owner, for example. It's complicated, and we'll get more in depth in it, but for now, we'll worry about the workbook, worksheet, and range objects, because these are really important in writing Excel macros. Now, to bring our primitive back, if you want to set a value to a primitive, you just use the variable's name, equals, and then whatever you want to set it to. For an object, it's a little different. If we say w equals this workbook, it's not actually going to work when you run the code because you need to put the set keyword before it when you're working with objects. It's a little confusing, but it's just one of those rules of the language that you'll pick up sort of as you continue programming. Now, the last thing I'll talk about is the debug.print method, which is just used to output things to the console. So the typical thing you print is hello world. And if I'm running this by pressing F5, by the way. It's just a shortcut. You can also click the little run button up here. And you can see if we click it, it outputs hello world. So this can be used sort of to track, if you want to clear your console, by the way, Control A, backspace. This can be used to track what's going on in our program. So say we declare a variable here, a is integer, and we say a equals 1. We can say, wow, what is the value of a? And we can see that it is 1. Now, if we do a times 10, or a equals a times 10, we can again say, oops, we don't want assert. Assert is, well, we'll talk about that later. Debug.print a, and now we can see a snapshot at a different time in the program where a has a new value. So this is really good for keeping track of more complex programs as they run, or if you're just using the code as some sort of calculation for giving yourself the final value of the calculation back at the end. Now, hopefully that wasn't excessively ranty. You know, I tried to go off a script a little bit, but these are a lot of complex ideas, and I'm trying to boil it down a lot. So if anything didn't make sense, you know, just keep at it, and things will make sense sort of as we continue running through these videos. But that's it for the first episode of this tutorial series. And in the next, I'm going to go into a little more depth on operators that act on variables. So like this is times, you know, there's a plus, a minus, etc., etc. I'll also be talking about conditional statements, which is what you would use a Boolean for, and arrays, which is how you hold multiple values. So be sure to subscribe so you don't miss the next video, and thank you for watching.